So we're finding the gravitational field here at P, right? So masses are easy, right? The gravitational field's always toward the mass. So the gravitational field of B is toward B, right? So here's our G of B. It's just straight up, right? All of it's in the y direction, right? And then this is pretty easy too, right? This guy is the gravitational field due to A is toward A, right? Right? So the gravitational field due to A is straight toward A. The gravitational field due to B is straight toward B. So we're just going to add these guys as vectors. I don't know why I drew that one bigger. It's much smaller, right? Oh wait, no, A is a little bigger. Oh, it's a great controversy. Okay. So our first step is to find the magnitude. So G of A is equal to, and this formula is in the data packets, GM over R squared. Right, so it's going to be 6.67 E minus 11, right, times A is 1.4 E12, right, and then we're going to go divided by, and then our distance to A is 2 over 2 down, those are meters, right, so it's 2 squared plus 2 squared, and of course it's the square root of that, and of course the square root is squared, so it goes away, right. So I'm going to go alpha F1, grab that fraction, 6.67 E minus 11 times 1.4 E12. I just made it that so that like the gravitational field would be something like 14 or something like that. Okay, and then down here I've got 2 squared plus 2 squared. Okay, so this is 11.6725, and that's newtons per kilogram. And this is, let's see, down, right, and down at 45 degrees with the x-axis, right? Okay. So let's find G, the gravitational field due to B. This is going to be straight up. This is kind of fun. Okay, so this got to be 6.67 E minus 11, and then B is 1.2 E to the 12th. Okay, and then its distance is 2, 2 squared, right? That's 2 meters, right? Okay, so let's go, let's grab that thing. I'm so lazy that I grabbed the same expression and changed it. This the 2 to a 0. Okay, so let's see. And then this is 1.2, right? B is 1.2. Okay, 1.2. And that's 20.01. Okay, and this is just newtons per kilogram up. There we go. That's easy. That'll make one of the components easy, right? Okay, so let's see. Wink. Okay, so let's go G, the gravitational field due to A, gravitational field due to B, and then A plus B. Okay, let's put our X components here and our Y components there. Somehow making all these little grid lines just makes me so happy. Really does. It's one of the simple pleasures of life, I think. Okay, so let's do A. A is this guy at 45 degrees, right? I always check in, you know, it's like so easy to be on cruise control. Okay, so this is going to be the X component is going to be positive because it's to the right. It's going to be this way. The Y component will be negative, right? Okay, so let's see. This is, technically speaking, 11.6725. And then this angle's 45 degrees, right? Okay, so it's going to be, technically speaking, cos 45, although it doesn't really matter, right? Okay, so I'm going to go 11.625 cos 45. And I get 8.2537 newtons per kilogram, and then that is in the x direction. And of course, this will be 11.6725. Since it's the opposite side, right? It'll be the sine of 45. But that doesn't really matter. It's still 8.2537 newtons per kilogram, and that's in the y direction. Okay, so let's figure out B. Oh, B is easy, right? None of it's in the x direction, and all of it is in the y direction, right? So it's 20.01 newtons per kilogram in the y direction, because it's straight up, right? There's no, yeah, I love that. Okay, so this guy is 8.2537 newtons per kilogram x direction. Then we got, oh, there's some controversy here. So let's go 20.01 minus the 8.25 guy. 11.756. So it's still positive, right? So positive that, positive this. Newtons per kilogram in the y direction. Let's see if I can draw a picture of this. I think we're going right and up, aren't we? Kind of, I'm so spacey. Okay, so here we go. Let's draw the right. Let's go up even more. The vector does this. Should meet that, but it's so hard to draw. Okay. Okay, so let's find that angle. This angle is tan minus 1 of 11. This side is 11.756. This side is 8.2537, right? So it'll be the inverse tan of 11.756 over 8.2537. So second tan, I'm going to go grab this guy, the 11 guy, divided by the 8.25 guy. Right parenthesis, even though it doesn't matter, 54.9 degrees. 0.928. Yay, we got the right angle. Okay. Let's see. Let's find the magnitude. So this magnitude is going to be the square root of 8.2537 squared. That's a point right there. Plus 11.756 squared. So square root of the 8.25 guy squared plus the 11 guy squared. I'm getting 14.36 newtons per kilogram. That's this magnitude. That's that angle. Victory. All right.